Hello everyone. Our next topic is the acid-base equilibrium. Equilibrium is also established in acid-base reactions. What are the acids? Acids are the substances which neutralizes the base. And what are the bases? Substances which neutralize the acid to give salt. Now, there is a difference between alkali and base. Alkalis are, the soluble bases are called alkalis, soluble bases, while what are the bases? Insoluble substances which produce salts on reacting with acids, these are called bases. On this concept, we can say that all alkalis are bases, but all bases are not alkalis. Now, we will discuss a concept which is called as a Bronsted-Lowry acid-base concept, which is called as a Bronsted-Lowry acid-base concept. Acid-base concept. According to this, what is acid? Acid is proton donor. And what is base? Base is proton acceptor. Now this is acid is proton donor and base is proton acceptor. In this case, in acid Bronsted-Lowry acid base concept, don't use aqueous solutions always. It is observed just which substances proton donor and which substances proton acceptor. For example, if we put HClO4 in ethanoic acid, what will happen? Both of these are acid, but the percentage ionization of HClO4 is much more as compared to ethanoic acid. That's why now this acid will give proton and ethanoic acid will accept proton. Now this reaction between these two acids will establish equilibrium and it will produce just like this plus CH3COOH2 positive. Now this will be the reactions between two acids. Here no need of aqueous solution is required. The substance which has given the proton, this is called as acid. And those substances which has accept proton, according to this concept, this is a base. Actually we know that this is also an acid. But what happens after the transfer of proton? What happens? Now, this is the species which have negative charge and has capability to accept the proton. It means that now this is changed into base. A basic character is now present in this because it can accept proton. So this is transformed into the proton acceptor. And what about this? A property of proton donor is produced into this positively charged species. That's why this will be called as acid. Now, what does means? The acid which is present on reactant side that is transformed into a base. As the base which we are indicating is generated from this acid. That's why the base is called as a conjugate base of this acid. This is called as a conjugate base of this acid. Now, on the reactant side, ethanoic acid behaves as a base and after accepting proton, it is changed into positively charged proton, positively charged particle. It means that now our ability to give a proton is developed into this species. That's why it is changed into acid. So this is also called as a conjugate acid. that all acid and base according to the Bronsted-Lowry concepts after losing proton or accepting proton changed into respective conjugate acid or base. Now the strength of the acid depends upon that how much stable conjugate base of an acid is. If the conjugate base is very stable, then it will not accept its proton lost, so it will remain in ionized form and automatically the acid will be considered as a strong acid. But if the conjugate produced by an acid accept its proton immediately and does not remain in ionized form, and once again it changes into the original molecule, it means that the conjugate base of acid is very weak, unstable, and it can accept proton. That's why in this case we have actually what is done here using this ethanoic acid, we have decreased the acidity or percentage ionization of this acid. Chloric acid 7, the percentage ionization or strength or acidity is decreased by dissolving this acid into another acid. So now this acid is repelling the proton lost by chloric acid 7 back. That's why an equilibrium is established between these two acidic reactions. In this manner, the conjugate acid base are produced whenever an equilibrium reaction is established. We also know that there are some strong acids, for example HCl, for example HNO3, for example H2SO4, for example HClO4. All these are the strong acids. It means that whenever these will be added into other substance, especially into bases, definitely they will lose proton and the bases will accept proton. And if we put these acids into water, then just like HCl, whenever we will add into water, it will change into Cl negative and H3O positive. All these acids will behave just like this, as these are the strong acid. So whole of this process will move to the right in the product side. That's why these will not turn back into the reactants. That's why the reverse reaction is negligible in this case. So the establishment of equilibrium is not too much considered in this case, because these are strong and the strong substances ionize 100%. Similarly, for example, if we have QH or if we have NaOH, all of these substances on adding into water, these ionizes immediately. These ionizes and produce K positive plus OH negative or Na positive or OH negative. Now all these substances are 100% ionized. They will never combine again, never come back. So establishment of equilibrium in this reaction is also impossible, because this is not quite easy. They are 100% ionized in the aqueous solution. But what happens? When we use weak acid and weak bases? For example, we know that H2CO3 is a weak acid, but we never see a bottle of carbonic acid. Why? Because this acid is produced as a result of combination of carbon dioxide with water under high pressure, and it is formed. But the substance which is formed, that is immediately ionized, plus HCO3 is produced. In this manner, equilibrium is established between carbon dioxide and water, and then proton and hydrogen carbonate ion. That's why this reaction also indicates that the equilibrium can be established only if the acid or bases are weak. Similarly, a weak acid is also H2S. H2S is also a weak acid. Whenever this is added into water, what it will produce? It will produce only immediately H positive plus HS negative 1 in case of aqueous solution. So it means that here in this case carbon dioxide and H2S is producing H positive ion after reaction with water. It means that the nature of both of these is acidic. Similarly, if we take the example of weak base, for example NH3 is weak base. What happens? We know that it reacts with water, and after formulating a dative bond with what molecule? Proton, it produces NH4 ammonium ion plus hydroxide ion. Now, as this substance which don't have any hydroxide ion, but after the reaction with water it is producing hydroxide ion. That's why the nature of this substance will be considered as a basic in nature. Now, this is also basic in nature. Remember, in weak acid or base, equilibrium will be established and the reaction can be shifted towards left or right by adding the suitable reactants or products. But if there are strong acid and bases, then the reactions are almost 100% converted into products without coming back into the reactant. So the establishment of equilibrium in case of strong acid and base will become impossible. So this behavior, this equilibrium play also a very important role in industry, in so many other processes where we use this equilibrium for the beneficial process and also for the final product formation. I thank you all. I have explained all the concepts. Please comment, like, share and subscribe my YouTube channel. I thank you all.